right, Unit 1, Lesson 3, Relative Mins and Maxes. For us, we've already done the calculator work for this. It's just putting together those ideas with looking at a picture, coming up with the x and y values, and then determining the intervals. Right. So, first thing is we want to come up with a definition for relative max and relative min. All right. Within a graph, most of these are going to be polynomial functions, which means they're smooth. You can draw them continuously without picking up your pencil. You're going to have these mountains and valleys. The relative mountain and valley is the minimum or maximum, but it's not the ultimate min or max in the graph. We're just going to use them as kind of points of change within the graph. These become really, really important when you get to derivatives. You'll see that when you get to calculus, the next course, so that's why we spend a lot of time reviewing those. Example 1, use a graphing calculator to find all the relative mins and maxes of the following. So I'd like you in your calculator for y1 to enter the equation as you see it, and if you do that correctly, you should get a picture that looks like this. This is going to be one of the first ones in our notes that the numbers don't necessarily look really nice. If you don't get that picture, double check your symbols that you put into the calculator, your syntax. What I'd like you to then do is calculate, please, this point right here, which is a relative max. I want you to tell me the ordered pair that represents the relative maximum. So go into the calculate menu and calculate the max. It'll come up as an ordered pair. If anybody needs help, please let me know. So you're going into second trace, choose maximum, left bound, right bound, guess. Your x value should be negative 0.20. Again, you're not moving the cursor and estimating, you're actually calculating it. Anybody with issues? All right, you can go ahead and calculate the minimum value down here at the bottom, the relative min, same thing. Calculator, second trace, calculate, choose minimum. If you do that correctly, your relative min should be at 1.09, comma 3.95. Please do not round those to 1 and 4. We want the exact decimals for this activity. All right, now, this is not part of the slide, but I want to review the information with you of what you have. Let's talk about the domain. All right, here's your thought process you should have. Domain means how far left, how far right. So look at the picture. How far left does the graph go, and how far right? How far left does this go? Thank you. How far right? Positive infinity with no breaks. If I look at the actual function, do I have a denominator? Do I have an even root? No. So that matches to what we know about domain. So our domain is going to be negative infinity to infinity. What about range? How far south? How far north? How far down does it go? How far north? Positive infinity. So we've got the similar answer there. Now what we did yesterday is we talked about increasing and decreasing functions. Think of this as a roller coaster ride. You always read it from left to right. And the key here is the fact you have to focus on the x values. So what I'm going to do is I'm going to grab this black marker. You might want to do the same. And I want to focus on x value and x value. I don't care what the y value is when I'm giving my answers for increasing and decreasing. So notice the first part of my ride would be considered what? Is this increasing or decreasing? Increasing. So I'm increasing from negative infinity to what x value? What's the x value right there? Negative 0.20. What's the second part of the ride going to be? Decreasing. So I'm now going to be decreasing from negative 0.20 to 1.09. And then where am I, last part of my ride? I'm increasing again from, not negative, 1.09 to infinity. You're dealing with the x values. Do not use the y values when you report your answers. Questions, concerns? All right, let's move on to odd and even functions. All right, the easiest definition for even and odd is the following. When you look at a function, you divide it in half using the y-axis. So this has to be the y-axis. If you have a mirror image, you have an even function. Odd is a little bit trickier. Odd says if you look at the line y equals x, which is an oblique slanted line, it's the most perfect line, you're going to have a flip not only across the line, but also across into the opposite quadrant. That one's a little bit harder to see and define. But what I want to talk about is what's down here at the bottom. Okay? This is function notation. That's what you need to know and be able to understand. Right? So let's talk about it within the context of the picture. Let's say that this is the point 2, 1, and this is the point negative 2, 1. Okay. If I have a chart, I'm going to make an XY chart. Okay. Instead of using the letter Y, I'm going to use the notation f of x. Okay. Within my chart, I have the point 2, 1 and negative 2, 1. If you have an even function, you will see that x will change signs, but y will remain the same. X will change signs, but y will remain the same. So if you look at it here, notice f of negative 2 is equal to f of 2. If I plug negative 2 in, I get 1. If I plug 2 in, I get 1. That is the algebra relationship that you are responsible to understand related to an even function. You need this. So if you didn't write it down, definitely write it down. Moving on to your odd function. If I look at my odd function, right, I'm going to have an x and an f of x. Okay. So let's say this is 1, 3, just making it up. So this is going to be negative 1, negative 3. 1, 3, negative 1, negative 3. If you have an odd function and you're examining the points in a table, you're going to have a sign flip and a second sign flip. And you can see that down here. F of negative 1 is equal to negative f of 1. You take negative 1 times f of 1, you get the same thing as what you have here. If you read a math textbook, this is the definition that they would give you for even and odd. This is what it looks like in practice when you're actually examining concrete points. Questions? questions on that? Awesome. Okay, so now, let's take a look here. We have 3 examples. So by process of elimination, we are going to be able to quickly determine which is which after we start through some of these. Are the following odd, even, or neither? You give them an f of x value. My suggestion is you make a table. Okay? So let's make a table, and I'm going to plug in 2 values. I'm going to plug in 2 and negative 2. I would never use 0, and I don't like using 1 because of the duality of the ones. You'll find that you have some issues with that, so I like to pick bigger numbers, 2, 3, etc. I'm then going to take my x value and I'm going to plug it in. Remember, instead of y, we're technically dealing with f of x. So I go to my f function, I plug in this x value, what do I get out? Plug in a 2. 6. Plug in a negative 2. What do I get out? Okay. Silence. Mental math. Plug in negative 2. Negative 2 cubed is negative 8. Subtract negative 2. So negative 6. Okay, looking at that table, is that an example of an even, an odd, or a neither function? It's going to be odd, so that's the answer. Odd. Okay, this is odd. All right, take a look at the next one. Same thing. Create a little miniature table for yourself. Easiest way to check this, let's plug in 2 and negative 2. What do you get when you plug in 2? 4 plus 4 minus 1 is 7. Yep, we got that. And negative 2. Negative 2. 4 minus 1. Negative 1. Does that illustrate any relationship? Nope, that's going to be your neither. So by default, we know the last one is going to be even, but let's still do a chart to make sure of that. So if I do an XY chart, and I choose 2 and negative 2, when I plug in 2 and negative 2, don't I get 0 out? Does that give me any information about a sign change? It's the same value, but does 0 take on a sign? No, which means we then need to continue the chart. So try 3 or negative 3. What do you get out? Plug in 3, 5, plug in negative 3, 5. So we're going to examine this piece of the chart. Does that illustrate even? Yes. We don't have a sign change, but we have the same number exactly. Questions? Alrighty, last one is your favorite. Graphing piecewise functions. All right, be honest. Who dislikes this the most? The mostest. You don't like it. All right, how many are ambivalent? You don't care if you have to do it or not. You're usually pretty good at it. And who thinks they're awesome at it? I'll raise my hand. All right, so here again is the tricky part of these. All right, and here's what I noticed yesterday in class. When you were asked to do the difference quotient problems on your own, that's another example of having to do math starting on the right and working your way to the left, taking what's on the right and plugging it into what's on the left. This is that same idea, okay? So I'm going to use colors. Again, if you're struggling with this, I would suggest going back and re-watching this video just for this section of it before you start these homework problems. The first thing we're going to do is let's start with the top function here. Start on the right. It tells me that I have to use x values, so here's my x-axis, that are less than or equal to 0. So that means I can start at 0 and I can use negative 1, negative 2, negative 3. I can use anything to the left of 0. So what I'm going to do here is I'm going to use my red marker and I'm going to box this off. Okay? I can only draw x plus 3 in this region of the graph. It cannot continue into the other section based on the restrictions that I was given to the far right. Now, my suggestion to you is this, and this is the new part for some of you that's a little bit confusing. Okay, I'm going to do this down here in red. I would make an XY table, and I would plug in the restriction value that I was given. So I would put in a 0 first. Is x allowed to be 0? Does it say x is equal to 0? Yes, which means when I graph this, I'm going to use a solid dot to represent that point. Okay? So I'm going to plug in 0. What do I get? 3. Okay, so I'm going to come over here. 0, 1, 2, 3. I'm going to make a solid dot. Plug in. Take this restriction value, plug it in, determine if it's open or closed, plot the point. Now, can I use the number 1? No, it's not in the restrictions, so I'm going to choose -1. When I plug in -1, what do I get? 2. So -1, 2 is here. It is a solid circle because -1 is less than or equal to 0. That makes the inequality true. The shape of this we should recognize as a line, so I can go ahead and draw this all the way through and graph that single piece. Are there any questions on the red piece? All right, let's talk about the green piece. The green piece here is y is equal to 3. That is a special case line. It is a horizontal line. But my restrictions say I can only draw it between 0 and 2. So now I'm dealing with this little green box right here. That slice or piece of the graph. I'm going to do the same thing I did here. I'm going to make an XY table. I'm going to pick the 2 points that are located in the restriction, 0 and 2. If I plug in 0 to here, it's 3. If I plug 2 in, there's no place to input it, the output is 3. Is 0, 3 a solution or a boundary point? Is it open or closed according to my restriction? It's going to be open. Any questions on why it's open? Yep, you're good now? Since x has to be greater than 0, it's a boundary point, makes it an open circle. So at 0, 3, 1, 2, 3, I'm drawing this open circle to represent the green. We're going to talk about that overlap in a second. But technically, this is open for the green section, and then 2, 3 is going to be closed because I'm allowed to equal 2. Okay? Then it's a horizontal line, so I can connect the pieces. All right, last section. Another line right here. I've got the line y is equal to 2x minus 1. Here's my xy chart. This says x is greater than 2, so now I'm dealing with this section of the graph alone to the far right. Where do I get my first x value from? This is important. Where do I pick the first x value from? Comes from the restrictions. 2 is my first x value. And some of you are like, yeah, but 2 is not true. Exactly. That's why it's going to be an open circle. It's not a solution, it's a boundary. If you start with 3, you're missing the piece of the graph between 2 and 3, all of those decimals. If I plug a 2 into 2x minus 1, what do I get out? 3. So I can go over to 2, 3. I can put an open circle there. Give me another value for x. I can use 3 because it falls over here to the right. Plug in 3, I get 5. That one will be solid because 3 is greater than 2. It's a solution. 3, 2, 3, 4, 5 up here. And we know this is a line, so I can draw that. So my piecewise function has 3 parts.